Hi. So far we're able to have our ball and drag it around our grid and draw a slingshot showing that we're dragging the ball. But there's one thing to our slingshot that isn't about right. We're able to drag it as far as we want. But when we have a real game, we want to limit how far we can drag our ball back. And that's what we're going to do in this video. So you can go over and switch over to IntelliJ. The first thing we need to define is how far you can pull back the slingshot, how long this slingshot can be. So I'm going to set a constant here, max sling drag, which is how far you can drag the slingshot back. And let's just set this to a distance of 50 here. Now that we have our max sling drag, what we want to do is, if we drag past it, we want to maintain the angle but not the distance. So if I pull back here, it should really only be going up to this far, even if I'm dragging over here. But the angle should still be the same. To do this, we can use similar triangles, because we notice that if we have our ball dragged here, we have a triangle here, formed by the start position of our slingshot and our ball. But if we want to scale down this hypotenuse to only 50, what we can do is we construct another triangle where the hypotenuse is of length 50, but all the other angles are the same. And these two triangles are similar triangles, so you can just scale down the x and y to get that new location for our ball. So the place where we want to change how we drag our ball around is an update sling end. So right now we're just taking the new end location of our sling and we're just setting it. What we need to do is first calculate the distance, check if our distance is less than our maximum drag. If it is, just set it. Otherwise, we want to scale down that drag. So what I'm going to do is, the first thing I'm going to do is calculate the distance, which is going to be the distance from our sling start to the new end. And what I'm actually going to do is I'm going to rename new end to maybe new end, because we're not sure if this will be our new end, because we might be scaling it down. So this is our distance. If our distance is less than or equal to our max sling drag, then we're going to set the new sling end. And here what we can do is, instead of using maybe new end, we can just use sling end dot get. So then all we have to do is, within our if else, all we have to do is set sling end, and this code doesn't have to be duplicated because we just depend on the value that was set earlier. But in the case that the distance is greater than our maximum sling drag, what we want to do is scale down how much we're dragging back so that it's a distance of 50. Now, to do that, we have to do a few things. What we first have to do is calculate the difference between the sling start and our max maybe new end. So we have maybe new end, which is a point on the canvas, but what we need is a point relative to the start of our slingshot. So to do that, we want to subtract points. So what I'm going to do is I'm going to create a method subtract, which we can just call minus here, which takes another point. And here we're going to find the difference between these 2 points. So we're going to return a new point. We're going to take my x and subtract its x, and take my y and subtract its y. So this gives us the new point. And now what we can do is, if we want to calculate the distance, which is what we're going to be scaling, we just do our maybe new end and we subtract our sling start. And now we're going to take this, we're going to be scaling it, so we want to multiply it by some scale value, and we're going to add this back to our sling start for our scaled location. Now, we need to be able to scale this, so we need a method multiply, and we need a method plus. So we need to implement both plus and multiply. So first we can do plus. That's pretty simple. We just copy this and replace all minuses with pluses. So here I'm going to take plus, here plus, and we can also implement multiplying. Here, multiply isn't going to take another point, it's instead going to take a scale, and here we can keep it as an int. And what we want to do here is take our scale and multiply our x and y by that scale. So I'm going to return a new point. It's going to be x times the scale and y times the scale. So now we have the ability to add 2 points, and now we want to multiply by our scalar. And what we want to do here is we want to scale this difference down so that the hypotenuse length goes from whatever it was, which is distance, down to max sling drag. Now the way we can just do that is multiply that by max sling drag divided by distance, because we know here our distance is greater than max sling drag, so this is going to scale the distance down. But the problem here is, one, max sling drag is less than distance. So if this were to be rounded into an int, it would be 0, and that wouldn't help us here. We need this to be a double. So what I'm actually going to do is change all of the ints in point to double, so that we use doubles everywhere. And now we multiply by our scale, which is going to be a double. This will compile. Another thing we can get rid of, because we converted it into a double, is rounding things to an integer here. So now what we're doing is we're taking our start, we're taking the difference from our start to the end that we requested, we're scaling that so that it fits within our max sling drag, and we're setting that to be our sling end. We're going to wrap this into sum. Okay, cool. Now we can go ahead and reload here, and now we see that as soon as I drag past the distance 50 that's set as our maximum, it doesn't drag any further, but if I move my mouse around, it does calculate the correct angle. So we get the angle, but the distance is still scaled down. So we're almost done with our slingshot. Now we have all of our dragging and preparation for slingshot ready. In the next video, we'll finally add it into our physics engine by shooting the ball out when we release our mouse. I'll see you then.